Hello everyone, I'm back again. So I came with this example. So my today's forecast is from the Turkey's comparison. I'm going to do the confidence interval for the protein in the water, and you can do for the rest. And I'll also test for the constant variance, or to verify if the variance are constant or not, using the Bartlett's test. So let's start. This is the given information. We are given the grade mean, which is 17.2 alpha, which is 5%. So we are given the nutrients as our experimental unit. So we have the our treatments, protein, vitamin, and water. Each replication. So we are given R1 replication for protein is 6. R2 replication for vitamin is X. It's unknown. For water it's 5. So we're given the mean. The mean for protein is also 4x plus 1 is yet unknown. So for the mean for vitamin is 14, and also the mean for water is 5. Except then we're given the error. So the error sum of squares. So what we're given here, we're given the summation of E1j square, which is 11x. We also have the summation of E2j square, which is 14, and the summation of E3j square, which is 10. So error sum of squares. So that's what we're having. So the total of this, it will give us SSE. If we add this plus this plus this, we'll get SSE. So we'll need that SSE because it is very much important for us to use it, especially in this Turkey comparison, what we are about to, because our mission is to compare. Under Turkey comparison, we're just only going to find the confidence interval for these two. And for us to find the confidence interval for these two, we need this minus this one compared with the value, compared with the Turkey. So we'll do that so you'll understand what I'm talking about. But first, to make this one easier and straightforward, let's just calculate x. So since if you may recall, the grand mean, our y dot bar, is nothing but, since we're having treatment, it will be given by the summation from I equals to 1 to 3 Ri y bar I dot, all divided by the summation from I equals to 1 to 3 of Ri. So since we can see that these replications for this is unbalanced, already we have 5 and 6. So even if here it can be 5 or 6 again, so it's unbalanced. So this formula, it caters both balanced and unbalanced. So we can continue. What is this is given by R1 y bar 1 dot plus R2 y bar 2 dot plus R3 y bar 3 dot, all divided by R1 plus R2 plus R3. So that's how we'll find our x. So what is this? Is 17.2 the grand mean. We said R1 is 6 into the mean of the first treatment, which we said is 4x plus 1, plus R2, as we said, it's x, we don't know it, plus its mean, which is 14, and we continue plus, then R, we are going to continue again, R3 is 5, then multiply by 5x, which is the mean of 3, all divided by 6 plus x plus 5. So this is a matter of simplifying and solving for x. So let's solve for x. So 17.2, if we cross multiply, we also add this is 11 plus x. So in here we have 24 x plus 6, then here plus 14x plus 25x. So multiplying this and this will get 189.2. Let me confirm if 17.2 times 11 is 189.2. Yeah, it's 189.2 plus 17.2x. So, which is the same as, so we add this 3, we have 63x. Let me just even confirm this one, 24 plus 14 plus 25, yeah, it's indeed 63. So, plus the 6. So, making x the subject, I can write 63x minus 17.2x is the same as you can see 189.2 minus 6. So my x is the same as, okay, so x is the same as, so let me see, 189.2 minus 6 is 183.2 divided by 63 minus 17.2 divided by 45.8, which is equals to 4. So we found that our x is 4, so which means the number of replication for the vitamin for the second treatment is 4. The mean for this one is given by 4 times 4 plus 1, which is 17, and for this one is given by 5 times 4, which is 20. So now we can try to perform our Turkey just we find the difference between the two. So but also I have to, this one, the sum of square of error for the first treatment is 11 times 4, which is 44. So our SSE is given by the sum of the summation from I equals to 1 to 3, and the summation from J equals to 1 to Ri of Eij all squared. So this one is nothing but the sum of E1 J squared plus the sum of E2 J squared plus the sum of E3 J squared. So we are just going to sum 44 plus 14 plus 10, and we're going to find 68. And this value is very much important because under this, we are going to compare we're going to find the confidence interval for the two means. We're going to find the confidence interval. The reason we're about to find the confidence interval between the water and protein, as I said, since we're able to find our X, so we're able to find our SSE. So for us to find our MSE, remember, is given by the degrees of freedom of the error, which is F. This F here is the degrees of freedom for the error. So it's actually given by N minus T, where T stands for treatment. So since in this case our N is just the summation of these ones, and we can see that it's 15, then we subtract our treatments, which are 3. So which means our small f, the degrees of freedom of the error, is 12. And for us to find the MSE, it means we're going to divide by 12 from 68. So to avoid of my values having a round of error, let me check. I'll just write that MSE as 68 over 12, that I can find the actual confidence interval. I'll round off after it. So what I'm interested, let's just read off this value from the table. We need Q of 0.05 with a number of treatments as 3 and 12. So the table that we're going to look at is this table called the critical values for standardized range distribution. This is the table we are going to use. So I'm going to tell you what is the value here for 12 and 3. So if I'm looking carefully, my value is 3.773. So my value here is 3.773. So since I'm from the table, so which means I can find this T alpha of 0.05, so which means I can find the confidence interval with this value for the 2. So what is therefore now we can find the confidence interval between protein and water. Protein, sample mean, and water. So we are going to find it as I indicated. Now I have everything which I need to just find this confidence interval. What do I have first? Y bar 3 is 20, then minus 17, which is for 1, then plus or minus. Then the value I read from the table is 3.773 multiplied by the square root. Then, as I said, we're having 1 over the R1 is given by 6, so it's 1 over 6 plus, and R3 is given by 5 plus 1 over 5. We multiply by our MSE, as I said, I'll write it as 68 divide by 12, since you know MSE is SSE over that F, where F is the degrees of freedom of the errors, then all I have to divide by 2, following this formula here. So whatever I'll find is the confidence interval. So I just have to punch this on my calculator and give you the final round of answers. So I also have to conclude. So I'll just write the final answer. When I subtract, it means I'll find my lower bound. When I add, I'll find my upper bound, as I'm doing in the calculator. So just have to be patient with me. Let me confirm the value is 3.773 indeed. Yeah, I'm not wrong about that value. Then the square root. So as I said, this calculator is a little bit crazy. Can I start restarting it? Then I can punch off. Hopefully you are doing it while I'm still taking time on it, so you pay attention to it. So 20 minus 17 minus 3,773 times, we have 1 over 6 plus 1 over 5, then this will be all in brackets as I'm writing here. So my lower boundary is negative 0.84566, and let me check my upper boundary or my upper value for this confidence interval. It's 6,84566. So how do I conclude? So my conclusion is that I'm going to conclude, since 0 is included, so we know that in this case, the means, if 0 is included, it means the means are constant. So if 0 is included, the means are constant. So the means are constant. So our conclusion, it will be, we just conclude on this. So you are going to say the protein mean and the water mean range between that value negative 0.85 and positive 6.85 at 5% of significant. That's how you conclude. Can I repeat? You are going to conclude. So my conclusion, I'll write it this way. Therefore, I'm having negative 0.8 let me round it to 3 decimals. 46. Then it's mu 3 minus mu 1 into, so we have that one 6.846. So this is how I conclude at 5% level of significance. Yeah. So hopefully you understood our Turkey. So this will take time. Let's ask now for C on the Bartlett test. How do we do it? Okay, so now let's check the constant variances using this Bartlett. This one is Bartlett's test. So this is what you have to know. So the first important thing that we basically have to be concerned about is our variances. The variance per each treatment. Because they are very much important for us to have them here to use. If you may recall, I gave you the formula when using these errors or the sum of square of errors. How do you find the variances per treatment? So this formula which you are looking for, the variances SI squared, since we are given the error sum of squares, so it's EIJ square, where J ranges from 1 to Ri, all divided by Ri minus 1. So since we know the sum of square of errors per each treatment, which means with this formula we can find the first variance, the second variance, and the third variance. So S1 squared is given by this first value, which is 44, minus the number of replication for S1 squared. So is what is, so it will be divided by 5. So this is 8.8. Then for S2 squared, we do the same thing, it's 14, then divide by our value, which is 3, since we have 4 replications for S2, and for S3 squared, it will be given by that last value, what is it, 10, then divide by that one, which is 4, which will get 2.5. So these values we're going to use, and our MSE, as I said, it is 68 over 12. So avoiding round off errors, I'll write it as 68 over 12, where I see MSE. So we have our test statistics in this. So we are testing the variance under this Bartlett. So variance for treatment number 1, number 2, and number 3, if they are constant. This is our alternative, our null hypothesis. Then we have also our alternative, which is H1, at least one of the variance differ. That's when we find out that this value is less than the chi-square tabulated, because we are going to compare this value with a chi-square of degrees of freedom of 0.05% with degrees of freedom t minus 1. So if we find out that our value this is less than this, we fail to reject, but if it's greater than, we're going to reject. So the normal way of doing things, so we can proceed. What is Q? Q is given by n minus t, so this one is 12. N minus t is 12 because this is just continuing with our Bartlett's test. This will be our Q and this is our C, where this n minus t is the degrees of freedom for the error and this is MSE. So Ri is for each treatment. So as you can see, this is the standard or the variance for each treatment. So we found the values. That's why, as you can see, this is how we did it. 12 log 68 over 12, then minus 5, which is 6 minus 1 for the first treatment, then log of 8.8 plus 4 minus 1 log of 14 over 3 plus 4 log of 2.5. That way we got this value. Then for our C, we used this one 1 over 3 into t minus 1, where our t is 3. So 3 minus 1 is 2. That's why I use this. So that's how I calculated it. Then I found that value. So we'll need this chi-statistic value, which is nothing but we take that whole value 0. We take that value which is defined by 2.3026, then we multiply by 0.718738216, then we divide by 1,117. Then we write the value. So let me just do this in a calculator. 0.718738216 divided by answer multiply by 2,3026. We get our value as 1,482. And what is our value? The tabulated chi-square of 0.5 of 5% with degrees of freedom, which is 2. If we can check from our chi-square table, I'm looking for the degrees of freedom 2 for 5%. The value is 5.991. The value is 5.991. If I can see that this chi-square calculated is less than chi-square tab. So because of this, I'm going to reject, or I'm going to fail to reject because it's less than. So in this case, I'm going to fail to reject HO and conclude that there is no difference among the variances at 5% level of significance. Thank you for watching. So Please keep on subscribing. You're all welcome.